next presentation ready to go. So up next we have David Tucker, and he will be doing presenting Make Trust Verifiable, Applied Cryptography. I can't talk today. Sorry. I'll let you talk about your things.
All right, good morning, everybody. Thank you for having me. My name is David Tucker. I'm a computer science professor for 15 years in Quebec, Canada. I drove all the way here. It was a fun experience. Sorry. So today I will explain a bit what I'm doing with my company on the side of my computer science professor job. And it's to integrate blockchain into real-life application, basically using cryptography to ensure trust. And I think it's something very important because the future will be hybrid. Everybody is talking about Web3, but the components of Web3, the fundamentals, can be applied right now without all the policies and regulations needed. The policies are necessary for all the financial aspect of it, so the DeFi aspect, and because you move basically money around, so you need those regulations. But you can still use the technology for its characteristic to integrate right now into many, many types of application. Next slide, please. So I will go through use cases. So 3 projects that I made, which is CodeQuill, Immunity Protocol, and lastly, Agrili. All of them includes like clever cryptography using blockchain technology so that yeah, we can ensure trust basically into the product. And also something I'm trying to do with the company that is very like novel, I would say, is to be able for the people to validate the trust themselves without having to trust my company Ophelios or the product itself. So this is the kind of thing a public blockchain can enable, is to make sure that everybody can trust into its cryptography, essentially. Next slide, please. All right, so that's about the presentation. So we will make sure that the cryptography itself can be verifiable. And of course, I'm a teacher, so there will be like code example on screen, so don't be afraid. I won't go deep into that too much, and I will try to summarize and vulgarize as much as possible. Yeah, don't hesitate at the end if you have a specific question on any topics for it. So it's gonna be pretty hands-on. And I did all the solutions I'm presenting, so don't hesitate if you have deeper questions later on. Please, next slide. Next slide, please. Thank you. All right, so at the beginning, like any kind of teaching, you have to know about the tools that you will be using. And I think this is something that's missing a lot. Everybody tries to go into AI or blockchain, but they don't really know the tool set need for that. I can do a little analogy because this summer I had some water problem with my house foundation. So there was like a crack in the foundation and I had to repair that, but I never done that before. I don't have any qualification to do that, so of course I paid somebody. But when I do that, I observe what he's doing so I can learn, right? So next time I don't have to pay, basically. And I learned a lot of tools because the crack was like leading to my parking with the asphalt. So we had to remove a part of the asphalt. And in my head, the only tool I knew was like a huge jackhammer, right, that exploded the whole asphalt parking. But then I saw this guy come with a little tool and he can cut a perfect square in the asphalt. And then I saw the tools he's using to make the reparation, and yeah. So now I can repair other cracks if it's happened. So this is the same thing for programming. As a teacher, this is the kind of thing we form our students, like we give the tool sets to acquire the knowledge to then do proper technological choices. So the blockchain itself is a tool, right? This is something you can use for their various properties. I will go over them very soon. But there are other cryptographic assets that we can use also and merge them all together. So one of them is the hashing function. So this is an important aspect of all cryptography and the blockchain, because this hashing function basically is a black box that you can input anything, any size of content in there. So you can input hello world, or you can input a movie script, right? Anything in there. And the cool part with this function is it will always produce a fixed character length output. And this is very important because the blockchain, as most of you may know, it costs gas based on what you're shoving into it. So the less data you input, the better. So you cannot put strings like characters, like letters on a chain normally. It's not good for the gas consumption. It will cost way too much. So hashing is a great way to do that. And cool properties of this hashing function is that it's one way. So you cannot, like with the result, go back to the original text that you input into this. So of course it helps for privacy and security. It's very much used in all aspects of cybersecurity, this function. Another cool thing is the Merkle tree. I will not go too deep into that. Basically, it's a tree of hashes. And yeah, this is a cool structure that we can use to basically combine many things together to have a single root hash that then we can publish on the blockchain for authenticity or whatever. And the cool part of it is you can do selective disclosure. So you can like prove that something was part of the tree at a certain time. So this is also another cool aspect. Another important thing are signatures and now passkeys. For those who don't know passkeys, this is the future, and it's happening right now. Very soon, the password-based application will no longer exist. Everything will be logged with a passkey. I'm pretty sure of it. There's no drawback to it. So basically, you can use a passkey to log into any type of application. Many applications supports it for 2FA. But the solution I do mostly, it's I use it in my solution for other purpose, but of course for the login. So no need for email, username, and password. So this is highly secure and it's unlockable with your phone. So yeah, it's very easy. One tap, it authenticates you with biometrics, and that's it, you're in. So passkey also is something very interesting. And with this passkey, you can be creative enough, cryptographically speaking, to basically sign certain transactions, certain things that ensure trust in the long run. And yeah, we have, of course, the on-chain anchor, so I will speak a little bit more with that. So basically, this is the blockchain as a tool of the toolbox. And lastly, we can have economic bonds to ensure, like, if you are doing a network, to make sure that it's Sybil resistance, meaning that people cannot attack the network because there's economic incentive behind the scene. Next slide, please. So the chain has, the blockchain itself has many properties that you have to understand if you want to use the blockchain, because I saw many people, not here specifically, but around and at school and in various projects that are using blockchain just like for the name of it, like a gimmick basically, but you don't have to use the blockchain if you don't need those characteristics. So one of them, and it's very important, is the immutability of it, meaning that what you put on-chain is forever. It cannot be deleted, it cannot be updated. It is there forever and ever, whether you like it or not. So, of course, it's not a good idea necessarily to put pictures, right, in this kind of environment for many reasons. You can have many nefarious pictures that you don't want there forever, for sure. And yeah, there's no like CEO or like call center for Ethereum, you cannot call Vitalik and say, hey, I uploaded like a picture there, I would like it taken down. It's not happening. So the network is fully autonomous and you cannot control like the deletion of it. It's impossible to delete nothing in there. So this is one of the characteristics. If you need this, then go for the blockchain. If you don't need this, don't use it. Use other type of technology. Other principles that are very important, no trust in a third party. Of course, I'm speaking more about Ethereum-based blockchain because you have permissioned blockchain, which I'm not very much a fan. I feel it's the same as a centralized database. So if you're going to do something blockchain related, I highly recommend to go with the permissionless one, like Ethereum and all of that. The reason for it is the trust. If you want the people to trust your solution and your encryption and your cryptography, you need to use a permissionless blockchain so anybody can verify basically its existence. And also the goal of a blockchain basically is to have the whole world witnessing the transaction and acknowledging that the chain itself is well done and there's no corruption in it. If a single company controls like 2-3 nodes of its own blockchain, it means nothing to me. Personally, I will not like trust this blockchain because I cannot myself assess it or access it. Another thing that is important is the proof of when that I'm using in many of my applications. That basically, when you put something on the blockchain, it's a timestamp. This is the whole concept of the blockchain, and it cannot be changed. So you have like a time anchoring that is very, very important for various applications that I will show you later on. And yeah, basically sensor resistance, so you cannot take it down and so on. But the core thing is very much the immutability, which means to the non-corruptible aspect of it. So let's say I am the CEO of my company, I hold certain stuff on chain for them. Someone nefarious cannot like bribe me to take down information. So this is also the kind of guarantee I think that government, regulator, auditors should expect going forward, like to ask their company to have a very deep proof, like with this kind of cryptography and infrastructure like blockchain, to prove that yes, it's non-corruptible. It's not, you cannot like go into the database behind the scene and rewrite history as you want. Next slide, please. So the three products I will present you, CodeQuill, Immunity, and Agrily, are all solutions that I made and mix those kind of tools. All right. So of course there's many other tools, but we cannot do a 45-hour seminar. So yeah, this is the principal stuff that I'm using as a tech behind. So yeah, you can go next slide, please. So the first use case I will present to you is the project called CodeQuill, and it answers the question, who wrote that code and when? So I need to give a little bit of context, and it ties in maybe to the previous speaker that was speaking about being too early. I think this solution maybe was made a little bit too early, but with AI now I have a good spot to market, I think. So the idea with this is when you write code, all right, because I think not everybody here is an active programmer, so I will just give a little overview. When you write code, you do certain type of checkpoints, right? You don't just write the whole thing because you can have like millions of lines of code. So at some point you have to do checkpoints, right? And this is an infrastructure that we call Git, all right? And it's a centralized thing that we upload on GitHub. The thing is, this GitHub, right, you can rewrite the history of how the code was made. And this is important now because of AI. So now AI produces the code at a speed no one ever seen ever, and they can do mistakes. But when they do a mistake, they can rewrite their own history all right? So because the history that is centralized on GitHub is not immutable, it's not non-corruptible. So you can move things around, you can rewrite history, you can delete part of history. And why it matters is if there's an incident. So let me give you a simple example. There are so many cases of supply chain attack. So let's say your code has something bad in it, right? And you are persecuted for it. And you want to basically defend yourself and all. It's very complicated because right now there's nothing that guarantees that this code at this specific time existed and you are the author. So this is why this solution is important right now. Please, next slide. So CodeQuill will answer those questions. So it's built on top of GitHub, all right? So it does not change the functionality. It's just that when you do your checkpoint, you can do a checkpoint into CodeQuill also, so to make sure that your code is immutable. It becomes non-corruptible, and then it can be accepted in court if you have some problem, or so you need to prove that no, there was no bug in this specific build, there was no bug in there and there. And I think this will be something very soon that will be required. And even I would suggest that a regulator, of course, enforce this kind of solution. Maybe not necessarily this one, but I think this is something that needs to happen with the advent of AI. We need some accountability for the code because whether you like it or not, the code runs your life, right? Everything from the medical, from the industries, the businesses, everything. And there's so many great talks that are happening about AI autonomy. AI will have their own businesses. They will create their own solution. They will move money around. This is code. Something has to be non-corruptible at its core so we can hold people accountable in the future. This is CodeQuill. This is the whole goal of it. And of course, it's using the blockchain. And when it's on the chain, then many features can sprout from there, and you can ensure trust into this. Next slide, please. So yeah, don't be afraid of the code. I will not go into it. I'm a professor. I needed to put some code in there. So this is just like a little bit of the core of the thing. How it's working, I'm combining the Merkle tree with the blockchain, all right? So how it's going is when you code, it will do a Merkle tree of the whole base of code that you have right now and build a tree of hashes, and the root will be on-chain. So this is how I can guarantee basically the non-corruptible aspect of it. So of course I can go way deeper after this seance. If you have questions, you can reach to me. It will be my pleasure to sit with you and explain all the deep cryptography, but basically this is how it's working. So yeah, I will not go too deep in that, please. Next slide. So the tree, what it can guarantee for me is the selective disclosure that I was telling at the beginning for the tool. So basically, you can prove that a specific file was in the tree without revealing the whole code base itself. And this is like game changer because when you have to prove something, sometimes you have to give everything away. So this is a novel way that you can just give one file but still have the cryptographic trust that is valid, and it was included into this code base. This is what is missing right now with the current solutions. So this is what CodeQuill addresses. So please. Thank you. So the CodeQuill, how it's happening, for that I went to New York Ed Global Hackathon last year. For those who don't know what is a hackathon, basically it's a competition for programmer, and eGlobal is one of the biggest players into the ecosystem of Web3 and things like that. They go around the world. They have multiple competition, and I did one last year in New York, and I presented CodeQuill. So CodeQuill was born in the hackathon, and I won a partner prize for it, so I was very happy for it. And then I worked on it like 9 months to, of course, rewrote everything, because the hackathon, you have like 36 hours to do something. You're not building a business product in 36 hours. So, but it validated the concept, the idea, and I had a strong signal, so I did all the work afterward. And then this year, I went back to New York Hackathon, and they gave me a special booth for it, a spotlight booth. So I was able to have more users, more feedback, and yeah, so it was a great experience also. Please, next slide. All right, the second use case I will go through is immunity. All right, this is a completely different subject. This product basically is to protect AI agents. All right, so what did the agents do essentially? So next slide, please. I will explain a little bit the context for it, because it's important that everybody in the room and looking online also understand what is an AI agent, because I think everybody heard a lot about AI agent, but nobody knows really what they are. So I will give you the rundown, all right? They are an infinite loop, all right? So this is, a loop is something that goes on and on and on infinitely, and they will repeat the same task infinitely. The first task that the AI agent is doing is context gathering. So basically, they will check online websites, they will check on Twitter, they will check whatever. I'm speaking in a way like a trading bot, right? A trading agent that you will set up, and you will tell him, all right, make me money, right? This is what people are doing right now, okay? They spun an AI agent, they gave him a wallet with like $500, whatever, and they tell him, make me money. So how does this agent reason? So basically, it needs external context. It needs to go online, it needs to see signals, to know what to buy, what to trade, and so on. So this is where this is dangerous, all right? So in this loop, it goes on to gather external context, then it will reason with the LLM engine, the Claude, the ChatGPT, whatever, and then it will create the transaction itself based on this reasoning and broadcast this transaction into the wild. And once a transaction has been broadcasted, this is impossible to roll back. All right, everybody that's been in crypto and doing transaction, you know this. If you miss something, too bad, you lose your money, all right? And I need you to understand something very important, that the models can be infected with what we call a prompt injection, all right? So basically, I can put some poison string into Twitter, into websites, into whatever, and the AI will consume this poison string, and it will affect its reasoning. And normally what we want to do as a hacker, for example, is to extract the private key or make the bot send all the money to myself, for example. So we can input prompt injection into this, and then the AI will reason and, well, produce the transaction, nefarious transaction, broadcast it, and the end, you lose your money. And right now, this is what's happening. All right, and all models are subject to various types of prompt injection. This is well documented. This is something, a huge problem right now in cybersecurity. All right. Next slide, please. So the solution I came up with, I went to France in Cannes for the hackathon, again, for the Global Hackathon, and I developed what I can call a firewall for prompt injection, basically for the agent. So the idea was pretty simple. It's, well, the process to do it was complex, but the idea is simple. Is like before you broadcast something, you check what the transaction is about. And you check with the initial prompt if there has been injection in there. And of course, I'm using AI to combat AI. Right? You cannot use a deterministic approach to combat something non-deterministic, right? So you need to fight fire with fire, and this is the only way you can go forward. So I'm using an AI in a chain link, basically, environment. I won't go into the detail of it. And it assesses if there has been a prompt injection or the intent, the original intent of the transaction is nefarious, because it also captures hallucination. And AI hallucinate, right? This is also a huge problem. So for example, you say, I will give money to Matt, but in the end it goes to whatever. So it can hallucinate, but you can protect it with this kind of firewall. So this project was called N-Shell, and at that point, and I won finalist spot at the hackathon, which is the highest distinction you can get there, and also partner prizes. And so there was a clear signal that it was something needed in the community. Please, next slide. Then there was another hackathon right after that was online also for EdGlobal, and this is where I came up with Immunity, which is basically the same concept but decentralized in a network way. So the idea I had was, all right, the firewall is cool, but it only protects like one agent, let's say. So let's do this, but a whole network that will work together to basically protect against injection and all types of attacks that can be done to an agent, because prompt injection is just one type. So the idea is pretty simple. When an agent protects itself, so it detects an injection, it detects an attack, it will create what I call an antibody. And it will propagate this antibody to the whole network, so everybody will be protected under a second. And the reason why is normally trading bots will consume the same sources, right? Remember at the beginning I said the attack comes from the outside. So they consume the same kind of website and Twitter posts. So if someone protects itself, it will protect the whole network automatically. So this was the core idea that I did, and I won also a partner prize. I used the 0G blockchain for this one. And it was a cool experience. Please, next slide. And then I went back to New York like the last month to the hackathon, and they had a new track where you can continue an existing project. So I did a V2 of the Immunity protocol, and I added the whole Sybil-resistant mechanism inside. So what does it mean? It means that you cannot lie, you cannot cheat the network, all right? I will give you an example that the previous version was bad. We are trading with Uniswap, right? Maybe people know Uniswap. This is a DEX. And this is a legitimate company protocol you can use, but someone nefarious could do an antibody for this specific application and basically deny access to a legitimate application and make money out of it. So, of course, this was a problem. So I came up with the Sybil resistance for the V2, and now the system is very highly protected. And the goal of this, when you make a network, is to make lying extremely expensive, so that it's not possible to lie anymore because there's nothing to gain from it. So I will not go into, of course, the deep details of it. But yeah, it's impossible to trick this system. You can trust me. I did extensive tests with hundreds of agents trying to attack the system, and they all go broke very fast. So this one finalist spot also, and partner prize too. So it was a great experience. Next slide, please. So yeah, this is how it grows. Basically, I did the firewall first, then I did the first version of the network, and the second version of the network was Sybil resistance and fully. Right now, this is a prototype. I will need some, because this is a protocol. I'm checking more for grant to continue this kind of solution. So yeah, and we'll see where this is going. Next slide, please. Yeah, we can stick there. Thank you. Which lead me to the last product that I'm making, which is my main commercial objective right now. This is Agrili. And I need to give a little bit of context. This is a very important topic we have. I come from Quebec, as I said, and we have a new law 2 years ago that passed called Law 25, all right? And this law is inspired by the European data consent law, right? So what it asks is all businesses that collect data from users, from clients, need their express consent, all right, to use this data. And you have to define like which data and for what purposes. So basically an email for marketing, the citizen has the right to reject this kind of data. So the company needs to comply and not use it, right? But how do you enforce this? How do you help the company first to be compliant to this extremely complex law? Right now, the companies are in disarray because they have no solution at all to manage this thing because it's very complex. I'm shortcutting the pitch of the law, but it's very, very, very complex. You have data retention, data destruction. You have so many policies in there. Yeah, it's a huge document, and the companies are lost because right now, how it's working, every company has private databases, and like it's a boolean, it's a flag in the database that this person gave consent, right? But this is not good enough for the law, not at all, for many, many, many reasons. So I came up with a solution called Agrily, which is in production right now, and it's been deployed like last week, just before I come here. And we are attacking the market aggressively with this one. Please, next slide. So yeah, the problem is that they don't have proper evidence system. And it ties back to what I said at the beginning about the corruption, all right? For auditors, for the government, and for the citizen, in this specific case, I think it needs to be non-corruptible, right? If I say to the company, don't use my email address for marketing, there's need to be some way beyond trusting the company to abide that we can ensure happens, right? So as a citizen, I'm concerned that they will not respect that, all right? So this is something, this is the core issue of it that I'm trying to, that I found a solution basically for this. And this application can be extended to any type of regulation. So I'm not sure if there's regulator-related people in here. I see government people, but I think that this is important to know that this kind of solution can be exported to any type of regulation. All right, and you don't have to trust the companies to abide and have audit to make sure that it's happening. We have the cryptographic tools and the blockchain to make sure that this can be trusted for real. So this is the kind of solution that I'm proposing. So basically how it works is when there's a consent request from the company signs this request, and then the citizen receives it by email, so they see what they need to give as a consent, and they sign it with their passkey, all right? So they have a cryptographic device that makes it sign, so they cannot say, I did not consent. So it goes both ways. It's good for the businesses, it's good for the citizens. So both people sign this thing, and then they have to enforce it cryptographically. So they can literally not access the data if it's not approved by the citizen. And often in solutions, like in businesses, we think about the clients, like the paying clients, for example. So my client will be the businesses, right, that wants to be compliant to this Law 25. They want to not have trouble with the government. This is my paying clients. But I think also about the citizen, and this is something Ophelios is special for. We build an entire free dashboard for the citizen to witness all the companies that they gave consent of data and what data they gave. They can revoke anytime. So let's say I gave marketing email consent, but I keep receiving spam and spam and spam and spam. I'm tired of this. I can just go into the application and revoke my access. And this is not like an infolet, a newsletter like unsubscribe. This is deeper than that. This is in their own databases of the company itself, that they can no longer use this email for this purpose. It's enforced cryptographically, and it's on a click, and it is respected at this exact moment, and all of those transactions and logs of access, because the Law 25 asks the businesses to give exact log of who access what data about what person, either with consent or not. So this is all on chain. So it's uncorruptible. Someone cannot like make holes into the logs, right? They cannot cheat about the log. They cannot cheat about the consents. It's all on chain and verifiable offline without my company. So an auditor from the government or anyone can check those claims themselves with, I did like something, of course, to simplify the processes for them, but yeah, they can verify without me. They don't have to pay me for the verification. So this is highly important. So basically, Agrili is good for businesses, for citizens, for the government, and for auditors. So yeah, we are trying to go hard on commercialization with this one. And yeah, we will see what will happen. So yeah, basically also behind the scene, I'm using a technology called decentralized identity, which is a standard by the W3C consortium. And they manage all the standards basically of Web3. And this is something I don't see much often used, but this is very useful. I will not go into the details of it, but basically this is a standard that can be assessed by anyone. So you don't need a centralized authority like my company, for example, to assess decentralized identity. That's the concept. It's a decentralized identity. So anyone can check it out. Next slide, please. What was complicated with this project, of course, many factors of it, but you can destroy an entire data, all right? So basically, not only you can revoke access to consent for the email for marketing, but the Law 25 also empowers users to delete the data. So not just the consent of it, but delete it in their databases. So I had to come up with some clever cryptography to make it happen so that you can delete it, but still the rest of the consent is still valid because you can delete one field, but the other one are good, right? So this is, well, a bit of a cryptographic challenge, but I did it with a Merkle tree and combination of private key stuff, etc. So you can basically delete a cell and it's working. So this is also pretty great. So yeah, there's 4 checks that can happen, and it implies zero trust in Agrili, all right? So the protocol is open, and yeah, you can basically validate everything without me in the loop. And I cannot, me as Agrili, for example, I cannot corrupt the ledger of someone. So let's say someone is not compliant because he was not respecting the erasure or something. I cannot, like, they cannot bribe me to erase logs. Right, it's on the chain. I cannot do anything. Just like you cannot unlock an Apple device. Even Apple themselves cannot unlock them, right? So this is like the same principle. So yeah, you can verify independently. I did a small application offline that a regulator can use basically to verify this. And yeah, I think it's very important. And I saw yesterday that Maryland has some sort of consent data law that was effective in April this year, and also that Washington has something very similar to Law 25, but for health data. All right, so this is something, this is the kind of thing I think that can enforce like this kind of laws, right? Because it's one thing to say, all right, everybody, you need to have consent of the citizen to all the data, but there's no technical solutions to enforce it. So of course, people do whatever they want. But now there's a solution, and this Agrili, I can make it morph into any kind of regulation. So yeah, the pattern I explained, generalized a little bit. So basically, it's a clever use of blockchain. I'm using it very much only for the things I need, which is the immutability principle, so the non-corruptible aspect of it, which is important for regulation and this kind of product. That can be, you can use like CodeQuill in court because of this non-corruptible aspect. It's not like something people can make up. Next slide, please. So yeah, that's about it. If you can remember one thing is to make trust verifiable, and this is something that I specialize in. It's very complex, all right? I will not say it's something easy. Each problem is highly complex to make sure that the solution is trustworthy and that everybody can verify this trust and having, overall trust into the product. So don't hesitate to reach out if there's anything. Thank you. Yes. Yeah, it's an update. Yeah, it's an update basically. Oh yeah, it's already all bundled. The latest version basically has everything, but it's not something you can buy. It's like you're using it with your agent, and how the economics working in this thing is that each time you're doing a transaction, you should check your transaction, right? So it costs 1 cent to check a transaction if it's legit. That's it. So it's very cheap, for real. It can protect you to save thousands and thousands of dollars. So this 1 cent will protect you against all type of attack that an AI agent can be subject to. And the cool thing is, let's say your agent got attacked, it protects itself. It will do the antibody for everybody else, right? The other person that pays the 1 cent, if they get protected because of your agent, you will get 70% of this 1 cent. So of course this is not huge, but you need to see it as a whole network, like maybe millions of AI agents connected together. It can ramp up pretty quickly. So yeah, this is the core economics of it, yeah. Yes? Mm. Yeah, basically it's an SDK, and the consumer, the build agent themselves can use it freely. And yeah, the provider could integrate it directly. Like if someone like provides AI agents already for trading, for example, which happens a lot, they could have a immunity integrated in it as an option, for example. So you disable it if you don't want to pay the 1 cent check. So yeah. Yeah, completely open source. This is an open protocol. Agree. Yeah, this is the one that we're pushing forward. And this one needed CodeQuill before, because CodeQuill was like the proof of concept for this kind of technology. And yeah, so CodeQuill also is commercial. We want to push it forward, but for now it's really much more about Agrili. And honestly, CodeQuill would be a great fit for like lawyers and people like this. So I'm also looking at the best strategic home for this project. So if somebody like wants to acquire it or something, I'm open to that also. But Agrili is really like our flagship product, and we have so much coming down the line, like in this kind of vein of products. So yeah, thank you for the question.
How does Ophelius integrate with other systems?
Hmm?
How would Ophelius, I'm just kind of wondering,
Yeah, yeah, yeah.
How would it integrate with other systems where verifiable credentials are being used? I mean, what we're looking at is, you know, I mean, South Carolina, if we can make South Carolina the first trust state, you know, I mean, using Dr. Meadows' project, Suremark as an example, you know, that provides us at least assurance that the, you know, the document or that
Yeah, 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 yeah,
is coming from a human.
yeah, yeah.
We have another project that provides a verifiable blockchain-based email
Yeah, yeah, yeah,
with all points in between, any attachments, and then, you know,
yeah, yeah.
all scanned down to the pixel. So I'm just trying to, I mean, you've got a unique project here. You know, there's not a lot out there for verifiable credentialing right now. And I really think it's a huge area.
Yeah, yeah. And we're not in competition with those because they all have their like principle. For example, the email verification. Yeah, yeah, yeah. So you complement each other totally,
Yeah.
totally.
So, I mean, I'm actually seeing overlap. We put together, I mean, I introduced, you know, Scott to Veritech, you know, the founders there. You know, they're working on, I mean, his project actually filled the need for their project to establish that the person that is actually sending
Hmm.
the email is who it is. I mean, there's no other digital identity option, you know, at this point. So I'm just trying to, you know, kind of wrap my head around how, you know, you know, this would integrate.
Yeah. So basically, Agree is really for consent, basically verification. So you have a product for your email verification, your identity verification against deepfake. I know the product, and yeah, Agree, for example, is to confirm the consent verifiability, and Code will verify the code itself. So this is something that is not existing also. So yeah, this is all complementary product, and I think more and more we go forward with AI agents and everything, we'll need those kinds of things in place. And I think it needs to come from the government to expect those kind of technology, because the technology is there. It's just that people don't want to go this way because, yeah, they like to do whatever they want, right, with the data. So, but there are ways to force them, like, to comply cryptographically. So this is where I'm at.
So this would be, I mean, okay, so if the state is, you know, deploying AI bots
Mhm.
or whatever, okay, like whatever, the, you would, they would come to you and they would use your package to guarantee the authenticity of that bot.
Yeah, yeah, they could.
Establish that that is in fact.
They could also secure it with immunity or like something similar, and authenticate the code that this agent is producing, for example. So yeah. And also, Ophelia, I forgot to mention, but we do consulting, training about AI agents and everything, and we do a custom solution also for all sort of problems with this kind of technology. So we need to sit down and see the proper case, and I can come up with a proper solution.
I've actually had something this morning come through my feed on one of our lawmakers in South Carolina that loves just to take a hammer to everything. And, you know, we'll talk about that.
Yeah, no problem. So thank you, everybody.